I do this? I'm going to take you guys for like a really cool in-depth look and talk to you guys a little bit about what we do here at SCHUNK and what we have to offer.
Sweet.
So right here, I'm standing in front of our FANUC automotive cell, and I want to start the conversation to talk to you guys a little bit about what can go into designing end-of-arm tools for industrial applications, and a lot of the thought process and considerations that design engineers have to make, and then kind of segue over into how we transfer some of these design considerations for custom tooling into standard products for cobots. So with industrial applications, usually the process is very specific. It has dedicated manufacturing processes, dedicated parts. It's usually low mix and high volume. So what you're really trying to do is optimize everything inside of the cell to be as efficient as possible. And sometimes that takes a lot of time to engineer. It also takes a lot of thought process. So some of the things that our engineers often have to think about are, what is the environment of the products that, where these end-of-arm tools are going to live. For example, is it going in a machining center? If it is, how dirty is that machining center? Is the coolant still going to be spraying, right? If it is, maybe we shouldn't use an electric gripper. Maybe we should be looking at just a standard pneumatic gripper, because generally you don't have any problems with any type of coolant because of that. So that's one of the considerations. For example, another one is if you're doing die casting, right? And you're going to put that part into a quench. You really want an IP67 sealed gripper. And so we make a bunch of those and use those in die casting. But as you get past the environment situations, you start having to think about, what you need for the application. For example, how heavy is your part, right? So you got to size a gripper for that part weight. And if you have a series of parts, usually you want to size it for your heaviest part. So that comes into consideration. So choosing the right gripper. And it's really easy for us because we have over 2,500 different gripper series. And within those gripper series, we have even more gripper sizes and serial numbers, etc. So once you get past speccing the gripper size, right, and then the environment, you might have to think about other requirements, like how much stroke do I need? How much stroke do I need to handle all the various parts that I have to go handle, because my part is either one part, but I'm putting it into, say, a Haas machining center or robo drill or whatever, and I'm going to take off about 10 or 15 millimeters of the part and then regrip it. You can either do that through stroke to regrip on that same dimension, or you have to design your fingers to be able to accommodate both widths of that part. So a lot of these custom tools, there's a lot of design considerations on the engineering side. And if you have those resources available to you, that's really great, because at the end of the day, you're going to design an end-of-arm tool that is specific to your manufacturing process, and it's going to work. It's not going to fail. It's going to be there for as long as that manufacturing process is around, and it's going to be, the robust solution that you're looking for. But let's say that, you're looking at implementing something very quick and something very fast and cost effective in terms of, that quick implementation. That's where we start to get into cobots a little bit more. People are buying cobots because they're at a good price point and they're easy to deploy quick. But the thing that can really trip you up on the end-of-arm tooling side is if you have a process where you need something specific to your application, if those standard products out there on the market don't work, right, then you're kind of stuck back at that original starting point of, hey, I've got to go either hire a design engineer to design this for me, or I have to spend the time and the money to figure this out. And then once I figure it out, I've got to design, or I have to machine and manufacture my custom components like adapter plates and fingers. So you can see on this tool right here, we have 2 grippers and custom fingers that we designed in order to pick up this crankshaft. And we used angular grippers, so we wouldn't have to need too much stroke as we picked it up. So there's a lot of things that go into designing these custom end-of-arm tools. And I just really wanted to show you guys from an industrial standpoint where that sits. Now, what I'm going to do here is I'm going to hand the camera back, hopefully, to Claire. And go ahead and just stop it, I guess. So we're going to stop that, so hopefully you guys can hear me a little bit better. If you can't, just let us know. We'll go back to that kind of point of view. We're going to start to shift over. We're going to talk about our general products and how we've adapted them for cobots. And we'll end at our cobot bar, and we're going to end with talking about a very specific gripper series we call Flexscript Tools, which is essentially a really quick and cost-effective way to go from custom end-of-arm tooling that we just showed you, that engineers had to pick out, design around, and create, to using standard componentry that's all out of a catalog and implementing it within a couple of hours. So we're going to stop at our accessories bar right here. These are all standard components for us. As you can see, SCHUNK has literally a massive portfolio of everything you probably ever want for your application. So right, here's a standard gripper. This is just a 2-jaw gripper, and we're branching out from this in all directions. So I'm going to start with this. These are all sensors. So those sensors, all of them have different functionalities or different reasons why you choose them. For example, we have sensors where you can program 2 positions, so you get a confirmation if you've gripped a part, or open close feedback, stuff like that. And then we have different types of sensors, like 5-position sensors to program 5 positions. We have inductive switches, pretty much the whole gamut of whatever sensor you need, we've got it for the gripper. Getting outside of sensors, right, we get into the gripper accessories. We make valves that port directly to the grippers, so you don't have to go out and figure out, okay, you know, I got to go buy a valve package from so-and-so. Now, we make it very simple, very easy. It's all 24-volt digital I/O technology, so no need to really worry about communication protocols there. Getting past that, we make different versions of the same grippers. So this is a standard gripper size for us. This is the exact same gripper series and gripper size, except this has a spring in it. We can offer it with a spring to close or a spring to open. It's still technically a double-acting gripper, since we do machine both ports here for open and close, but now you've got a spring in there in case you drop a part. It'll spring shut, or it can spring open if you have an ID pick. That's a really popular decision that's made in the automotive industry. Next, we have dust covers, right? So we can beef up that protection if you're in a really nasty environment, like some of those grinding environments. If you're doing any type of machine tending on grinding, right, you're getting these fine particles, these chips. Sometimes those can work their way into the mechanical guidance of any gripper. It doesn't matter whose it is. Those things have just a way of working themselves into the worst spots and ruining them. So you can add dust covers to add that extra little bit of protection. We also have a purge port on there to add positive pressure to help protect that even further from particles getting inside of the mechanical guidance. We make boots, we make finger blanks, so you can machine your own fingers instead of having to go out and buy a piece of bar stock and figure out how to machine it. We make sliding base jaws that go back and forth so you can get that grip position in and out on a part. We make quick change fingers that use a hex key, so a quarter turn, and it pops off and on. So if you have multiple parts and you need multiple sets of fingers to handle those, because it's very precise and you need that precision that we offer, we can help accommodate that for those quick changeovers. So I just kind of wanted to show this, and then on top we have our accessories, and these are really for application dependent. So if you have insertion applications where you need a little bit of give, right, or you need some kind of flotation as you're inserting it, we make compensation units that bolt directly to our grippers. Spring-loaded ones that just have essentially a rubber disc in them, so they offer very little compliance, but just enough that if you need a little give, you can have it. So now we're going to move over to our cobot bar, where the sound will be much better. And we're going to focus in on this half. and we're going to talk about tooling for the TM Cobot here today. And I'm going to start off with two products that are plug and play, right? So literally you buy it and you bolt it straight on, and you still got to figure out your finger solution, but we offer some standard stuff for that too. So the first one we have is literally called Plug and Work Portfolio. And what our Plug and Work Portfolio grippers are is our standard grippers that are industrial grippers. So they're made to last. They're made for those hard applications. Hell, they're even made for those easy applications if you really want something never to break. And the Plug and Work grippers, each one comes pre-wired with sensors. So the sensors are already ported up here. Inside of this intermediate cylinder, which this portion can bolt directly onto the robot, there is an I/O block in here for sensors. So we're handling your sensor communication up here. And also inside of here are two, excuse me, two valves so that you can do open and close on this gripper, right? This particular gripper is IP67. So it's really great for dirty environments. It can have massive fingers, longer than this. And we make an intermediate jaw if you want to buy our finger blanks, so that you don't have to do a whole lot of design work. So all of this is contained in here, comes out on a M8 8-pin wire, and we can connect that to what I've got here, which is a manual tool changer. So you can see this manual tool changer. The wire comes here on the tool side. This would be attached to the master side of the robot. The handle comes back 180. It's going to feed through the pneumatics, so your air for this gripper, as well as your electrics, which would go here, and it would pop right off. It's very rigid. It's very secure. This is all industrial equipment, so it's made to last, right? I mean, it's not coming out. It has a safety measure here. This pin has a lead in into a hole, which prevents this handle from flying back. You physically have to pull that pin all the way out in order to get that cam to unlock. So that's our Plug and Work series. We have two jaw grippers, long stroke grippers. We have high force grippers in that as well. And we've got a 3-jaw gripper. We also have a couple of electric grippers, one that I'm going to pick up right now. This is our Coact EGPC. We make 4 different sizes for the TM Cobot. And this is a certified collaborative gripper. So it has the safety, it meets the safety requirements for end of arm tooling. So it has a soft shell body on it. So there's no sharp corners. There's nothing that I'm going to hurt myself on here. There's no pinch points, unless you design your own fingers that way. But what's nice about this gripper right here is it's super cost effective. If you just need a simple gripper to pick up a part and you want to 3D print your fingers, or you're going to manufacture your own, it comes with the cable to go straight to the tool port, or you can get it in flying leads if you have something else that you're going to be putting on that tool port. So we can wire it up in the control panel of the robot. And it's very simple. The way you actuate it is you send a signal to say open and a signal to say close. So if all you have to do is open and close your gripper to grip on a part, then this is a fantastic solution for you. If you need to pre-position those jaws for any reason, we've got some other great options available. I don't have any on the table today, but if you reach out to us, reach out to EandM, we can start that conversation and talk about some of those full-blown servo options we offer. So that's Plug and Work and our collaborative EGP, which is our collaborative gripper here. Now we're going to talk about my favorite product, Flexscript Tools. This is our Legos, right? So a lot of what we've really been focusing on is you doing all the work, right? It's either got to be a standard single gripper, which is kind of plain Jane, but what if you got some specific needs because of how your machine's going to be set up or how you're presenting the part, right? So now we get into Flexscript Tools, which was that standard product to do custom solutions. So let's take a look here at the table. I'm going to start with this adapter plate right here. So Flexscript Tools all revolves around providing you with everything in what we call kits. So what I'm holding here is the first adapter plate that we would put onto the robot wrist, right? So we make a series of these plates. This bolts straight up. It has a dovetail rail on it. And this dovetail rail is where we connect our tooling. So the tooling connects via, right, clamps and connectors with dovetails on them that have screws and lock washers and everything. And this whole system is currently used in industrial plastic injection molding extensively, as well as some other industries that we're pretty deep in. But what's nice about it is, right, so you had that gripper, you could really only put it one way. You might be able to clock it a different way, but let's say you needed it at exactly 90 degrees, right? So you have your plate, you hook it up. We make 90-degree clocking connectors that clock directly to the gripper. And the gripper has its own adapter plate with the dovetail on it, so you can slide them off and on. So you could switch between this gripper, this electric gripper, this other electric gripper, this miniature parallel gripper, that 3-jaw gripper, or this 2-jaw gripper here, just by undoing the screws and sliding it out. So what you'll also notice is we have intermediate base jaws on our gripper fingers, right? So we can also adjust our fingers without having to get into the expense of servo grippers where, you know, you got this long stroke and you can pre-position. What we can do with these pneumatic grippers is, right, this mounting post actually slides along this, this dovetail. So I can change my grip position to a part that's about this narrow, or slide it out a little bit further, or bring it in a little bit further, or flip this entire post around. And I wish I had an Allen key on me so I could undo this. I hadn't thought that far ahead, unfortunately, on that end. But so what's really nice, though, is these finger kits are standard components. So if you're a machine shop or you need to implement something extremely quick, right, if that's your mission, this is a fantastic solution because you can adapt it to whatever your needs are. You're not forced into a standard solution that has very little flexibility. So continuing on here, I really like this tool a lot, this design, because it's actually a design we have out there on one of our industrial arms. And this is used a lot in very tight spaces for machine tending, right? So you have it on the end of the robot arm, like so, and you go in and you pick a part like this, and then you're going to come in and you're already at this angle, so the robot doesn't have to do too much manipulation to place a part into a vise that's on the edge of an auto door, for example. So this is a very realistic industrial style tool, and what we have here is our robot adapter plate. We have some offset, some right angle brackets to make a offset with a piece of our dovetail extrusion, and then a variable angle connector, which if you undo these middle 2 screws, you can actually swivel this all the way around. So you can adjust that angle to whatever your need is. So it's very convenient. And then I wanted to show a deconstructed tool here, right? So you can understand how this all gets pieced together. So we have our robot adapter plate up here. We have these right angle brackets right here, right? And they're really simple, right? It's got that dovetail on it. And I'm only gonna do one because it's boring to watch people turn screws, but you see it just slides on. And you can even unclamp it all the way and clamp it on in the middle if you've already pre-assembled some of it, right? And then it all kind of fits together really simply. So we've got this right angle. You add the other one for a little more support. And you can already see that we're starting to create an offset so we can get more reach out of our robot, right? And then this would go on the end with these two. And you can just see that if the way you set up your robot, because it has to reach into the machine, that either you can't reach all the way in because it's too deep, or you have to reach down to grab a part below your pedestal. Something like this would be really cost effective and really great to have, because you might not have realized that until you were setting up your robot. So now we're gonna end on this product right here. This is also in our Flexscript Tools packaging, and this is a machine tending setup. So what we have here is we have, and I'm going to start at the wrist and come down. So, right, we have a different style adapter plate. So this adapter plate bolts directly to the wrist like so. And then what we do here is we can also offer it without the valves, but we've tried to make everything super easy for everybody. This right here is a valve package. So there's 4 3-way 2-position valves. There's 4 sensor IOs. So you can have 4 sensors out there. So you know if you get open, close feedback. And you can actuate all of these grippers and receive the sensor IO all within this block. It's got 1 cable that'll go down the arm. So really bringing down the number of cables and tubing you bring up. And it's 1 tube in. So you don't have to worry about bringing 4 tubes up or, 1 big tube and then having a couple of Y splitters or something like that. No, it's very concise. It's very easy. And it's all 24 volt and it's all actuated via digital IO. So it's not hard to program it. It's not hard to actuate these grippers. We use our variable angle grippers in order to make this connection. Tool plate and everything's kitted. So we include the adapter plates, the screws, the fittings. The only thing we don't include is tubing. You're going to have to get that one yourself, but not too bad to get. And on this setup, we've got our finger kits, which we have 2 styles of finger inserts, dual V-jaw for cylinders, as you can see here, rubber pads for that increased coefficient of friction if you want to pick up heavier parts with a smaller and lighter gripper, or you remove either one of them and we can use just a flat metal post. So that's my presentation, guys. I hope I didn't take too much time and that you can still hear me. Were there any questions?
Thank you so much, Mark. Hopefully you can hear me now.
Yep.
And we can hear you loud and clear. We've got about 6 minutes left for some questions for you. And we do have a handful. So someone is wondering if it's better to design your own end of arm tooling if you have a dedicated process that only runs maybe 1 or 2 parts. Is it worth it?
So my opinion is if you have only 1 or 2 parts or really anything less than 5 parts or 10 parts, and it's dedicated, to take the time if you have the resources, and that's really what it comes down to. If you have the resources to, work with a SCHUNK application engineer and help you pick out grippers like these and design custom tooling to what you're going to do, it is 100% worth it to go down that route, because at the end of the day, your process is specific to what you do in your manufacturing plant. And you can only get 90% of the way there if you use a standard product. If you want it to be truly optimized to get the most out of it, right? So it always comes down to, in your own manufacturing facility, if you've ever had to create something because no one made something perfect for you, that's kind of the mentality of, is it worth it? The answer is yes. It's always worth it to invest money into your own processes.
Alrighty. And then someone is wondering if your Flexscript products come assembled when they're delivered, or if you have to put them together yourself.
So the way we ship these is you buy a kit, right? So for example, you'd buy a gripper kit, which is exactly this. Typically, we don't assemble the plates or the adapters on them to keep the boxes smaller. But it's really simple. It's centering sleeves and a couple of screws, as you can see here. If you wanted a fully assembled tool, pre-assembled and shipped out in a box from us, then we can do that. It's just, you got to tell us exactly what you want. We have to assemble it because the whole point of this is it's Legos. You buy a Lego box, you can see the picture. We've got suggestions on how to do things, and we can offer instructions. But at the end of the day, you can decide to deviate from that and create whatever you want. So we do ship it unassembled.
Awesome. Yeah, I was about to say, I don't think I ever expected my Legos to come pre-assembled for me, but you never know. And then what kind of applications do you normally use your flexible products for?
Sure. So probably the most popular one we get called about is machine tending, because that's kind of our bread and butter. We make vices as well, and we do have a new low-cost vice for machine tending. For anyone wondering about that, reach out to EandM and they'll contact me and we'll send you all the new literature on it. It's really a one-of-a-kind thing because it's low cost, it's robust, it's everything that you would expect from a company that does precision machining. So machine tending is our number one. Pick and place is probably our number two. And general assembly is our number three, since we do make quite a few components like compensation devices that help with insertions and stuff like that.
Cool. And then here's a really interesting question, at least for me, because I don't know the answer. How many sizes of the collaborative grippers are there available?
So these are this is what I'm going to call our collaborative gripper because it's certified collaborative. There are 4 sizes of this and a couple of different variations. And we make a whole slew of different types of fingers for them if you need a standard finger. We do have a couple of other collaborative grippers, and by that, they're not certified, but we did design them according to the safety standards that are set out in that, whatever it is, like 15T66 or the Who's He What's It one. You know what I mean? The one that everyone always talks about for a bajillion years.
Awesome. So I'm assuming that hopefully more of the products will become collaboratively certified as well.
Yes, we do have some other products that are on that list.
On that track. Awesome.
Yep.
Cool. Well, that's all the questions I have here. We've got about a minute left if anyone has any more burning questions that they would like Mark to answer. But other than that, thank you so much, Mark. Or maybe Andrew's got a question.
Yeah, I have a question to add, and what do you have in the way of choosing the right bill of materials for a Flexscript gripper? Are there tools to help you with that?
Yeah, so the easiest tool is to contact a SCHUNK sales rep because we live and breathe the product. We know our part numbers so well. But if you want to do some research on your own, we do have a brochure which has a step-by-step guide and runs you through how to pick out components with an example bill of materials at the end of that brochure.
Okay, cool. Thank you.
Awesome.